We need to really understand the holistic design, the environment it goes into, the way it's packaged and box build and final manufacturing steps, level 3 and 4 manufacturing, 5 even, and how that attributes to the overall reliability of the product. And that is a very hard thing to figure out. It's not easy.
That's my guest, Dr., Professor, and SMTA President, Dr. Martin Anselm, next on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Dr. Martin Anselm is a professor at Rochester Institute of Technology, or RIT, and is also the newly elected president of the Surface Mount Technology Association, or SMTA. Martin also worked for Universal Instruments. During his 12-year career at Universal, Martin was, among other things, a process research engineer and manager of failure analysis services. Martin completed his Ph.D. in materials science and engineering through Binghamton University. His research topic involved copper nickel tin intermetallic formation kinetics on electroless nickel substrates. Martin also completed a Master's of Science in Mechanical Engineering from Clarkson and an undergraduate degree in physics from SUNY Geneseo. Here's my conversation with Dr. Martin Anselm. Welcome to Reliability Matters. Thanks for being my guest today.
Hi, Mike. Nice. Very happy to be here.
Yeah, we've seen a lot of each other over the last several weeks with
virtually.
You and I both joining on the with SMTA. Me as a board member, you as the president of SMTA. So welcome aboard. I guess we can say that to each other, right?
Welcome back for me, at least, right? I was on the board for 6 years and had a year off and back. And I'm very excited, Mike, to have you on board on, no pun intended, because I think you bring a lot of really great energy to the team and a great amount of knowledge, too, within the industry. So I'm really super excited for you to be a part of the board of the SMTA.
Thanks. And if I can be part of the Mutual Admiration Society, it's great to have a professor president. And we'll get into more of what that means in a little bit. But this particular episode is a little bit different. Normally, I'll bring a guest on who's a subject matter expert in one thing, and we'll talk about one thing for an hour. So we're not going to do that with you. You are obviously very well rounded in electronic technology. So I want to take you for a test drive. Let's just talk about stuff that interests both of us, and then we'll do a little technology test drive, and then we'll get into SMTA and what's going on there. I know there's a lot of exciting things in that department. But let's first talk about one of my favorite subjects, and we get to geek out here now. So we get to dive into the weeds. And my expertise in this industry is contamination related failure mechanisms and cleanliness quantification and contamination mitigation and improving reliability through the removal of potentially harmful residue species on circuit assemblies. So that's fun at a cocktail party. Try explaining that. What do you do?
Yes.
Yeah, it definitely clears a path. So if you need to get to the restroom and there's a line, just start saying what you do.
And it causes narcolepsy.
Yes, exactly. I tell people that, I can tell you all about what I do. It's better than Ambien, and it's certainly not addictive.
Right. Exactly.
But at any rate, one of the lesser known and fascinating failure mechanisms that are contamination based is conductive anodic filamentation, or CAF, which is a subterranean problem. This is a problem between the layers of the board. And when you and I kind of compared notes about what we want to talk about today, CAF ended up on your list. I was very excited. I'm like, oh, good. I get to talk about CAF to someone who knows something about CAF. So what's your experience with that particular failure mechanism, and how did that make it to the top 10 topic list for you?
Well, I had the benefit of actually having the opportunity to do failure analysis on a number of different CAF failures. When I was an engineer at Universal Instruments in their advanced process laboratory, I was a failure analyst and looked at thousands of various different failures in solder joints, in manufacturing, in material set analysis. And one of the more, I guess, rare, I can say, failure modes, and I don't really know how rare they actually are, because we in the industry often come across no fault found failures, kind of a bones pile of circuit board assemblies that we don't exactly know what's going on with them, but we know electrically they're not performing right. It can be something obvious like a short, or it could be just a conductive path that's changing the dielectric strength of the material or the resistance or what have you. And over the years, the CAF ones were the real satisfying failures to find, to be able to point at what is effectively a smoking gun. Everybody wants to be able to say, I know exactly what went wrong. Very often in our industry, it's a combination of lots of different things that went wrong in a perfect storm scenario that caused a head and pillow, or an open or a non-wet or something like that, or a short of any kind. It's not just one issue. It's a culmination of a lot of different problems. But CAF, if you find it, you're like, there's this aha moment. I found the actual failure mode. I can see the little piece of copper growing through this interior, as you mentioned earlier. It's a subterranean failure inside the circuit board. And I can think of two really, really good examples of failures that I saw that had two distinct and very different root causes. And we were able to come to root cause primarily by understanding the circuit board fabrication process, and B, the circumstances of the CAF growth. So where the separation occurred, what did it look like, over what distance did it go, things of that nature. So it was a big win, and have some great photographs that I can't share, but it's really fascinating to see the different CAF growth mechanisms, essentially.
Yeah, several years ago, I got a call from a lawyer, and that's never.
I've gotten a few of those.
Right. So it's like, my secretary said, there's this lawyer on the phone looking for you. I'm like, oh no. So it turned out to be a cool thing. He was searching for an expert witness, which I ended up being retained for, on a CAF matter. And these were circuit boards that were, I have an NDA, so I can't say exactly what they were for, but that really doesn't even matter. They were buried in the ground, and they were connected by a radio frequency to a receiver on a traffic pole, on a light pole somewhere. And the board that was buried in the ground was operated by a battery. It was powered by a battery. And that it was a 10-year battery, and those batteries started to fail after about 6 months, even less.
Wow.
In 3 months, the batteries would go out. And the
Sounds expensive.
Yeah, the only remedy was to dig a hole in the street and dig up the part and trying to figure out what happened. Well, you can already connect the dots. They had all sorts of problems. They had a CAF problem, and they had a surface ECM issue, dendritic growth, and they had a lot of parasitic leakage, and it was just eating up the battery. So they determined it through microsectioning and all this kind of stuff for the CAF. Mm-hmm. It's pretty much do a surface inspection for the surface. And long story short, first thing when I was hired, we started going through the statement of work. This was a intellectual property owner who had this idea, who patented it, and then sent it to a contract manufacturer to produce. The inventor of the product, the owner of the IP, really didn't know much about electronic assembly. And in the statement of work, he specified the laminate material. He wanted the CM to go ahead and take care of buying the boards as well. So under the statement of work, under the board description, the words "down and dirty FR4, nothing special." That was a quote.
Oh, really?
Down and dirty. I don't know
classic.
if that's a flash sheet, that IPC has buried at the bottom.
Haven't encountered that one.
Right. Down and dirty. But that down and dirty remark, pretty much lost in the case, because that set the intent. Their intent was, we don't want anything quality, just down and dirty, just give it to us. And then of course the CM followed the instructions, and then got sued for following the instructions. So there was
Right.
a lot of takeaways from that, a lot of lessons from that. But the major part of the problem was calf, and there was dry weave and inadequate resin flow between the layers, which created the pathway for the calf to follow. But they could have, at the end of the day, solved all their issues had they just baked their boards out prior to encapsulation. They did no bake out process at all. And they thought they were safe by encapsulating the board so all the bad actors couldn't get in. But in essence, they trapped all the
Trapped it inside.
inside. All the bad actors were
Yeah.
inside the outcasts. So they partied. They did little ECM parties and killed the board. But
Yeah. Right. And the one example that I have is exactly that. It's, the glass weave wasn't properly filled. That grew a calf essentially between two adjacent vias over a very long distance. The aspect ratio of the size or diameter of the calf relative to the distance it grew was enormous. That was one example. The other example I had was actually just dull drill bits. During the drilling operation for via prior to plating. And those drill bits effectively delaminated the interior of the board. A lot of people don't realize sometimes these drilling operations are not just your single board. It's stacks of multiple 4-layered boards with a backing material on the back. And if that backing material isn't right, if the drill bits aren't retipped often enough, if you're not using getting new drill bits, it's more of a punching process than a drilling process.
Right.
And we saw evidence throughout the entire board in flat sectioning. And I should say I'm more of an experimentalist, right? I did all these cross sections myself. I was sort of the detective in trying to find these. We were doing systematic flat sections. We background so we can use transmissive light, and it's very challenging to find these things. Through very systematic analysis, we could see delamination and all the woven glass fracturing on every single hull. But it was a situation we had to find, because who the customer was and how much revenue was at stake here. We had to find that failure, and we did end up finding where the calf was in one of these delamination zones. And it was very satisfying. The company was very happy. We actually we hired a statistician to look at how many opportunities there were on a board where the two vias were close enough, and how many occurrences there were out in the field in terms of number of failures. And there was some Coffin-Manson calculations that were done to predict for this particular customer over the next 6 to 12 months, how many field returns would they expect to see. And it helped them decide whether or not they were going to do a full recall, which would have been sort of a big black eye and it's hugely expensive, or if they were going to, as a part of their preventative maintenance that they had for this particular product out in the field, if they were just going to go replace them systematically over the next 2 years as they went to places all over the world replacing these. And based upon what we found, it was, that we were expecting only 1 or 2 failures a quarter, and they decided not to do a recall. And 5 years later, I talked to that very customer and I asked, well, hey, how did we do? Right. And they said they found just about the number of failures we had predicted, maybe a few more, but not all of them were attributed to calf. So there's all sorts of different ways, using statistics, using failure analysis, understanding the failure mechanism to help people out in making business decisions. So really, it was an eye-opening project for me. It was early on in my career. It was really great to be involved in something like that.
Yeah. One of my favorite questions that I get asked is, what's the difference between quality and reliability? And in my mind, two completely different subjects, right? They are interrelated, but quality does not guarantee reliability. So tell me about your input on that statement. What's the difference between quality and reliability?
Well, this is just like you said, they're interrelated, and it's something that as a failure analyst, I understood pretty well. But when I came to RIT and I started teaching sophomores and juniors about electronics manufacturing, I took a fair amount of time to really, throughout the entire semester, sort of drive home the difference to my students of these two terms. Usually the way I start the conversation is the IPC 610 standard, when you look at class 1 through 3, and is the solder joint meet some sort of a metric that should give you a certain amount, A, first quality, right? And then B, there's an expectation for a certain solder joint size and shape to give you a certain amount of reliability. But in my opinion, that's about as far as the relationship ends. And really understanding reliability needs a further step in terms of the quantification and the experimental testing, and maybe using some models to understand how that product, given let's say a class 3 quality solder joint, will survive out in the field. And what really applies here to taking that leap from, yep, it's class 3, we have all these solder joints, they pass class 3 quality, to that leap of reliability is design, its test, and its materials, right? I can have one circuit board material, I can have a surface finish, that both of them have quality solder joints. But then, where is that solder joint located? Is it right next to a tooling hole? Is it in an area of the board that experiences a lot of vibration? Is it in an area of the board that not only sees the environmental impact of temperature swings, but also maybe very close to some voltage conversion or something like that, or a BGA that's generating a lot of heat, and we have local heating going on. It could be even something, and this is probably an area you have a lot of experience in, like a fan blowing air over an area, and all of a sudden you have failure modes in terms of corrosion that are accelerated because of flowing gas. That is really a design consideration, and therefore the reliability tanks, right? So we can't just look at something and say, yep, check it off, the quality is there. We need to really understand the holistic design, the environment it goes into, the way it's packaged in box build and final manufacturing steps, level 3 and 4 manufacturing, 5 even, and how that attributes to the overall reliability of the product. And that is a very hard thing to figure out. It's not easy.
Right. In our world, it really is all about intended environmental application or in use climatic environment. That is a huge game changer. So, in our world, it's all about a tolerable residue. How much residue is tolerable on an assembly? And that answer is a sliding scale, because in order to say, yeah, your board is safe with a certain amount of residue, I need to know where your board is going to go and how close the components are to each other and what the standoff heights are and its reflow profile. But the most important criteria is where's it going? If it's going on an oil platform, it's not very tolerable to residue. If it's going in an Amazon server farm, it could probably be pretty dirty and survive. So, and the whole world now, and I've ranted on this, my audience is probably sick of hearing me say this, but the whole idea of IoT, of Internet of Things, where we're putting electronics and things that really have no business having electronics in. Connected toothbrushes are the poster child I like to point to all the time. They actually is a connected toothbrush that will connect to the internet, to your Wi-Fi, and let you, kind of narc on little Jamie or little Johnny on how long they brushed their teeth and how vigorous they brushed them. But that's a harsh environment, and that's clearly a class 1 device. It's no one's going to die if it fails. So we're taking a lot of class 1 devices and putting them in harsh environments, which is a game changer in terms of how they actually function. So
I'll give you one more anecdote, and that is where I can see my students' eyes light up is when I use this thing as an example, right? And I use this quality versus reliability concept when I talk about your year-long warranty period for your phone, whether it's an Android or an iPhone, and customer, what's the word I'm looking for? Loyalty, right? So here we want to make sure there's enough quality. Apple or whatever, Samsung is interested in having enough quality so they don't have a lot of recalls, right? It's going to be very expensive to them. But they also design for reliability so that in 5 years, when it's time for you to change your phone, 3 to 5 years, used to be every 12 months because the the telephone industries would, AT&T would give you a new phone every year, but not anymore. They're too expensive. So
Right.
let's say 3 to 5 years. Apple and the Android phones want to make sure that your phone survives that long so that you become a repeat customer.
But
So
not
they
much
have
longer.
these two metrics, right?
Not much longer. I think there's a little bit of planned obsolescence as well. I don't think.
Oh, there is. I think that's in the
Yeah,
software, though, not necessarily in the hardware. But
you're right. All of a sudden,
right.
the processors can't handle the giant loads of software that are required to run the phone with the latest, update.
But that my engineering students understand. They understand that there's a bottom line cost associated with quality if they can't get the phones to survive a year, right? And that they break super early because they have a poor solder joint or the design is so shoddy, right? Then it becomes a really big problem.
Sure.
But there's also an expectation for the reliability. And how do you predict the reliability out those 5 years so that you're going to go buy another phone from the same manufacturer and be pleased with the performance, right? So all these different things. I need to come at this quality versus reliability from a lot of different angles so that eventually with our students, by the end of the 14 weeks, it sticks on some level.
Yeah, no, very good. Let's switch the subject a little bit over to your day job. In addition to being the president of the SMTA, you also have a real day job at Rochester Institute of Technology. Tell me what that's about and what your role there is, and what kind of students that are under your purview.
Yeah, so I've gotten really lucky. I've been able to make that transition from industry to academia pretty smoothly. The reason is that RIT here has a focused degree program in electronics manufacturing through a master's program. But even before the master's, we have a few courses that undergrads can take that can learn really electronics manufacturing and the industry itself. My students, the undergrads as well as the grads, don't know what a BGA is. They don't know what a laminated FR4 board is and how it's fabricated, and no really concerns about design. And many of these students, if they're electrical engineering majors or sort of electromechanical majors, which we have as an undergraduate program as well, they're designing circuit boards. They're designing circuits in order to achieve some sort of an electrical function. So our students here learn a lot about the industry as a whole, and I bring my experience from failure analysis and working with OEMs and the EMS industry into the classroom. RIT is also a co-op school, so very often I have students that go out on co-op after their sophomore year and come back after having worked in our industry and say, what courses does RIT provide that I can learn more about contract manufacturing, electronics manufacturing, and packaging? So they find me, and it can be over a number of different departments, not just our own department, and they come and take my course because that next block of co-op might be back at Apple again, and they want to go back with that same experience and may turn into a permanent job. We at RIT have over 95% placement of our students after graduation, and that's primarily because of the co-op program and sort of the practical education experience that they have here. And if we're lucky, some of those students will transition into our master's program where they can actually get a concentration in electronics manufacturing. And as a part of that graduate program, they have to do a research project, a capstone or a thesis. And I can mentor as many as, I've had as many as 6 or 7 students at a time. The least I've ever had is maybe 2 or 3. It doesn't last very long. And all these students have to do some sort of experimental research that they can do with me because we have the Center for Electronics Manufacturing and Assembly. We have an SMT line here at RIT with advanced equipment. Our equipment is probably just as good as almost any contract manufacturer out there. We have selective soldering, we have reliability testing equipment, we have cross-sectioning, we have amazing microscopes, on and on and on. So you can basically do any kind of experimental and analytical work here.
Oh, that's excellent. Let's put RIT on hold for just a moment. We're going to circle back and talk more about RIT, but I want to make sure that we have plenty of time. I don't want to make you late for your students. I don't want to think that this podcast is
They'll be happy with that.
I don't want to give them an excuse, right? I think it's one of those things where if you're not there within about 35 seconds after the class starts, they just leave, right?
Yeah, the professors want to call it a 10-minute rule. In fact, I think it's maybe 2 to 5 minutes if you're lucky.
Right, exactly. So we don't want to give them a break. But let's talk about SMTA for a bit. You are the newly elected president.
Very proud of that. Yeah.
Call yourself, yes, you should be, and I know you like to call yourself appropriately the professor president. So,
trying to coin that trademark is pending there.
Yes, exactly. Tell me how your this is probably the first time we've had an active professor as the SMTA president, at least that I look back on kind of the past presidents, and I couldn't see any evidence of that. So if you're not the first, it's the first in a long time. So tell me, what unique perspective do you think that will bring to the SMTA?
Yeah, so that's not an easy question to answer. I have a lot of different ideas of how that is going to shape or formulate my presidency. I've just been in the position for about a month. It's a 2-year elected position. I'll have the opportunity to rerun for one other term. But just to give you a little history, I was the chair of the training committee on the board prior to becoming the president. And for me, not just in training, but in terms of the community that we have in the SMTA, and it really is that, it's very camaraderie. We have a great community within our organization. It's all about building value. So, as a goal for the SMTA, it's about sharing knowledge, sharing experience. It's this idea of process versus product. We can't necessarily talk about our products because of the IP situation. You and I had this problem when we were discussing CAF, but we can talk about the process. We can talk about the challenges and how we overcame them like we did today. And sort of condensing that, figuring out how we can turn that into a greater value, not only for our members, which is obviously the heart and soul of our organization, but also for our chapters. We are a local organization that has a global presence. And these local chapters are our first ability to actually shake hands and meet people face to face. It's difficult now with the COVID crisis, obviously, but my presidency is really going to focus in the next 2 years on how do we add value? How do we improve the networking? How do we share the information between our members over the next 2 years? And really, my goal fundamentally is growth of the organization in terms of membership. I want to see more and more people understand the value of being a member and joining at a very nominal fee to be a part of the organization as a whole and continue to gain value. If you go to the SMTA website and you go to the events page, it's shocking, even under a current COVID crisis, how many events we as an organization have and how we're trying to basically evolve and change under this, no contact COVID time that we're living in right now.
Yeah, talking about events, we just concluded SMTA. We just concluded the
live portion.
The live portion.
It's still going till what is it? The 23rd, I believe, right?
October 23rd. So now there are about 100 technical presentations that are available to stream on demand if those are paid events. So if you paid to be part of the technical symposium, you have access to all of those events. And I said this before, but I think one of the great advantages of a virtual event, we certainly know what the disadvantages are. We can't hug and shake hands and, go
Right.
out for drinks and things like that. But one of the silver linings of this is that unlike a live event where you walk down a hallway and there's 3 presentations going on at 11 o'clock and you want to see all 3, now you have to make a choice.
Right.
It's now possible to view every presentation. I mean, if that's what you want to do, you can view every presentation on demand. You can start it and stop it, just like Netflix. So it's.
Yeah.
I think that's a huge value because you cannot get that at a live event. You have to kind of pick and choose what you want more than something else. And then we also have live professional development courses in our future. I think we've already had 1 or 2, and I think there's another 6 or 7 or so to go. So those will be going out between now and the 23rd of October. They're live. They're 3.5 hours long. They're a la carte, so you can purchase the course you want and avoid the one that doesn't interest you. But they are live instructor led, which means unlike an on demand where you can email the author questions and hopefully get answers in a timely manner. This is live, so you will have a presenter not recorded presenting live for 3.5 hours with plenty of time for Q&A. I think that's a huge value.
Yeah, I totally agree. I can't help but get this visual in my mind at the SMTA show in Chicago last year, where many of my friends, either rolling their suitcases or carrying their backpacks, had the event guide open and had multiple things circled. Oh, I want to go see this. I want to go see that, and complaining very often that they can't see everything that they want to see. And
right.
Some companies had the benefit of having 2 or 3 employees there, so they kind of split and decide, all right, you go to this track, I go to that track, so we can see everything and we'll compare notes. But now, just like you said, everyone can go to anything. You can see all of the ones that hit your top 10 list. You can see all those presentations. And what's nice about the platform is you can ask questions in the platform. Hopefully the authors will add their comments there, but we also are using Discord, which is a free chatting app similar to not similar to WhatsApp, but WhatsApp or some of these other texting apps where we have channels in Discord for all the different sessions, and people are ready. I've been on there chatting away. The other thing I wanted to say, Mike, about the event SMTA is that even though they're not live, we'd still have the expo floor open, so you can go and see the booth spaces and reach out and see all the materials that are there. And I've heard good things from attendees and from the exhibitors in terms of how interactive it is. It isn't flat. It's sort of, you're almost like you're walking up and down the aisle, so you can see the booths and how they're arranged and have lots of different types of information available to you. And it was very interactive during the time that it was live, but it's all still there, and you're able to go and see the videos and the things that are on display at each and every booth. So I encourage everybody who watches this, if they're watching it in the appropriate time, to go look at that. But, as SMTA evolves, we expect in the future, even after the social distancing ends, to keep some of these new technologies and in part that add value. And this brings me back to what we said earlier, to add value to our members and our attendees. So we don't know what that is yet. It's based upon customer feedback and member feedback on what they liked and what they didn't like, and things like Discord or other platforms that can be used for networking and discussion can stick around. I like Discord, and not to belabor the point, but I compare it to that hallway conversation. You got out of that talk, and you and your friends are in a little circle asking questions about the talk or sharing ideas or things that you experienced relative to that topic. And that Discord channel could be similar, right? Except the great thing is you can hear what everybody's talking about. Just like going to a session you may have not been able to go. Now we can hear what people are talking about and chime in if we feel. You don't have to be in that little circle of friends. Oh, there go my lights. Sorry.
Oh, you have to move once in a while, right?
Yeah. So I think this is really exciting time. We're going to find that certain things are very beneficial for networking and sharing of information, and some things we really didn't like, and that's something we're going to have to figure out.
Well, we'll weed out what wasn't a hit, and we'll amplify what was a hit. And I agree with you, Martin. I think after this pandemic is over, I was saying this earlier to a guest in a prior recording, that we all have like grandparents who went through the Depression, and it altered them forever,
Mhm.
right? It changed the way they view the world, particularly economically. I think now we are being altered. We are now, quote unquote, children of the pandemic, and I think it'll change the way in the future that we view social interactions to a degree. And I think that the world has discovered the incredible efficiencies of virtual meetings. They don't replace physical meetings. There will always be a need and an application for physical meetings, but not everything has to be physical. I think
Right.
what will end up coming out of this is, I can see us offering more virtual events in addition to physical events, and the virtual ones will not just be a consolation prize; they will be a preferred method of meeting and networking, because
Right. I agree.
great. I mean, you don't have to get on a plane. You don't have to get on in a hotel room. Your boss doesn't need to approve a budget. They don't need to worry about
Right.
what illness you're going to catch and spread around the factory when you return. I mean, I think we're going to be in the virtual world for a long time, both by need and by desire.
Yeah, and an example of that is our chapters, right? And one thing we heard even before the COVID crisis was, if I'm in Rochester, New York, I'm going to have a hard time getting people from Utica or the Albany area to our events. And we only get a certain number of people because it's going to be within maybe an hour's drive, and it's hard for people to get out of work and not be home after work and things of that nature. So it was something that prior to the COVID crisis, people weren't ready to embrace. But now that we've lived on Zoom and other platforms for a really long time, and had a number of events like SMTAI that I think went off really, really well and are continuing to do so, that maybe these local chapters can embrace a little bit of this technology. We know how to do it. It's not so scary anymore. We know the connections, the internet speeds are going to be there, and have the interaction. And now, rather than having a couple dozen people in a room, or a dozen, or even less in some scenarios, you could have 50 people chiming in or connecting through maybe multiple chapters, collaborating together and having that one guest speaker or what have you. There's so many more options now that I think people are more comfortable with.
Well, all three California chapters have hooked up and are going to produce a technology day on December 8th.
Perfect example.
Commercial. Thanks for the segue.
December 8th, you said. I talked over the date. I don't want to do that.
December 8th from 9 a.m. Pacific to noon. It's three California chapters that are putting it on, but the nature of online meetings is anyone can join. So if you're in Hong Kong, or if you're in China, or if you're in Europe, or anywhere in the U.S., and you're connected to SMTA, it's obviously available to you. So you can kind of be the fly on the wall to watch the three California chapters produce this event with three technical speakers, and Martin, you're gonna be there virtually.
That's right. And I think just to say one more thing on that is, regardless of how the event is put on, the draw is the technology, right? If you have three really good speakers and it's a topic that hits home with people, whether it's a live event or a virtual one, that's what's going to draw the people in. Conversely, if you get something that no one cares about, it doesn't matter if it's a live event or a virtual one, people won't take the time out of their busy schedules, quite frankly. They have important things to do to attend. So I think the SMTA is really good at that, right? Because we are a practical community, since we are all doing manufacturing, we're all overcoming challenges. We're a community that understands what the touch points are and what people are struggling with. And I think that is another reason why the SMTA is so successful.
Yeah, absolutely. I'm looking forward to seeing what the silver lining is with the pandemic and how it lands on SMTA. I know it will. I can kind of see it forming already. I know that you, as the new president, have pretty much given marching orders. You call them charge documents to all the board members of what you would like to see them accomplish. I'm chair of the training committee, which is your old stomping grounds, and you've given me a lot of things to do with my group to beef up the training assets that SMTA has. So I'm looking forward to that. I'm taking that as a challenge. I know the other board members and staff are thinking the same thing, and we're all really united in increasing the value proposition and just shining it as a bright light in a dark cave. What the value proposition of SMTA is, and how being a member of SMTA can enrich your career and improve your networking and give you way more access to technical knowledge than one would get without being a member of SMTA. So I'm looking forward to helping be part of that team to build that even further than we have already. And I have a lot of confidence that we'll get there. Before I let you go and educate the world for people who will hopefully be taking care of us when we're older. So I don't want you to miss out on that opportunity. Tell me a little bit about RIT's training program, specifically for veterans. That sounds a very interesting program.
Yeah, being here at RIT, it's opened my eyes a little bit more in terms of other areas where education is needed. As a failure analyst, I was very focused and was basically an expert in finding root cause. But when I came to RIT, it sort of opened my eyes in terms of what the industry needs in terms of different skill sets. We're training here 4-year prepared engineers, but if you talk to some of the local contract manufacturers and military OEMs that do SMT, they're in dire need of manufacturing tech A's and manufacturing tech B's, people that are, supporting the SMT line with making sure the feeders are running, that all the material sets are ready for production, so there's no downtime. So through a program here in New York State, it's called a consolidated funding application, which is a very strange name. But we had the opportunity to gain some funding to actually do some workforce development for local veterans that were underemployed or unemployed. So we, in the last 3 years, did 2 summer programs where we trained veterans in the area of electronics manufacturing. Not only did we give them the background, that I gave them sort of a piecemeal overview of what I teach my students in the electronics introductory course, but we also did a little bit on quality and a Lean Six Sigma. We have another professor here that specializes in that, and they were understanding, peanut butter and jelly manufacturing, right? How can we streamline the process and have less defects while manufacturing more sandwiches? And this is something they really understood. And then the following 2 to 3 weeks, they actually got certified for a number of different IPC standards. They got training and certified for 610. I think they got the J001 as well. They did a hand soldering activity. So they left what is a 3 to 4 week program. We did it 2 different ways in the 2 years that we did it with a brand new skill set. And a lot of companies, especially if they're military OEM, have incentives for hiring veterans. So we had a pretty good placement rate. About 80% of our veteran trainees were placed in local Rochester companies, and we're looking in the future to expand that if possible. The New York State funding fluctuates a lot. Some years it's there, some years it's not. There's a lot of hoops you have to jump through. We're looking to communicate with the federal government to actually expand the program, and it would be great. I'm hearing more and more community colleges and universities are starting to understand the scope of the electronics manufacturing industry. It's everywhere. You can't shake a stick and not hit a company that has an SMT line in your general area. So Wouldn't it be fantastic if we could actually take what we're doing here at RIT and basically condense it and spread it across the country? So, it's unfortunately like anything with the federal government, it's a very slow process. We have something that works here. If anybody watches this video, I invite them to contact me to see how we can collaborate either through funding or creating another satellite training facility. So, it's something that I don't have any veterans in my family, but my colleague who does the Lean Six Sigma, his father was in the Marines, his brother was in the Marines. We have an ROTC program here at RIT. We all really value what these individuals have given to our country. And it's a real shame that some of these individuals struggle with finding gainful employment. So why not train them to have a skill set that's quite transferable? If they leave Rochester and they move to California and they move to the Midwest or they move wherever, they can still use this skill set that they have wherever they go. So that's the idea. And we could hope to continue to do it. I applied again this summer for that same funding, and hopefully this coming summer or even throughout the semester, if we win the award, we'll be training another set of veterans. So it's a great program, very fulfilling, very different group of people to train than my students. Training a 20-something who doesn't ask any questions and just wants to get an A in their grade versus someone who's been out in the field and questions. I've had one veteran every single slide in my 100-slide presentation. He had a question. I couldn't get to the end. I was already prepared to I'm looking at you. Right? He's going to ask me a question about what was on there. And it was really fulfilling for me. I loved the heck out of it. It was so much fun to teach those people about electronics manufacturing because they had life experience. Some of them had been a mechanic fixing, tanks out in the field, and they didn't take anything for granted. So I really enjoyed that.
And they're very MacGyver-y. They figure out how to fix something, even if it's not the prescribed method to fix something. They're usually
and we get into soft skills too. Not to go on a tangent here, but part of the reasons why they're having difficulty finding jobs is sometimes they don't have a filter, right? They right and believe it or not, we get into those type of topics too, and we're thinking about ways that we're going to improve the courses in the future. We recognize that there has to be a component of soft skills training as well. New York State does not, in the way that we were applying for the funding, offer any funding for soft skills training. They wanted to make sure it's technical, and I can understand the value of that. But in the future, we were looking to collaborate with some industry folks to maybe supplement the course with some soft skills training workshops as well. So it's not an easy thing to solve, but it is very, very fulfilling, I have to say.
Well, thank you for agreeing to be my guest today. Thanks for everything you're doing in educating veterans and students of other types. And thanks for all the effort you're putting into and you will be putting into SMTA. I really look forward to seeing the fruits of all of our combined labor.
Yeah, I agree. Thank you so much, Mike. It's been great.
All right. Take care, everybody.
Bye-bye.
Well, that's another episode. Thanks for listening to the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on iTunes, Spotify, iHeartRadio, or wherever you get your podcast. Reliability Matters and other reliability-based podcasts are available at Circuit Assembly's PCB Chat at pcbchat.com and at Ascendo Reliability at reliability.fm. Thanks for your comments. Please keep them coming. Send comments and episode suggestions to Mike at mikeconrad.com. That's Conrad with a K. Until next time, thanks for listening and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.